Hello, I'm Russell, and welcome to the Articulate Journal, where I'm exploring what it takes to build an AI-native architecture from first principles, through the design and implementation of a reference architecture for architectural intelligence. This isn't a tutorial series or a product demo. It's a public engineering journal documenting the architectural decisions, experiments, and lessons learned as the architecture evolves. In the previous episode, I explored the idea of treating architecture as knowledge. That information exists across different architectural domains. A business capability may be supported by application components. Those components may depend on data, integrations, and infrastructure. Decisions explain why parts of the architecture exist in their current form. Principles influence those decisions. System characteristics provide constraints that shape the resulting design. The knowledge model gives Articulate a way to represent this information and, importantly, the relationships between it. But representing knowledge creates another question. How should AI reason with that knowledge? This is where the problem becomes more interesting than simply retrieving information. Imagine asking Articulate a question. What would be affected if we replaced our current messaging platform? Finding information about the messaging platform is only the beginning. To provide a useful architectural answer, the system may need to identify which application components depend on it. It may then need to understand which business capabilities those components support. There may be architectural decisions that explain why the messaging platform was originally selected. Those decisions may have been influenced by particular system characteristics or architectural principles. A proposed replacement may satisfy some of those constraints while conflicting with others. The answer, therefore, does not exist as a single piece of information waiting to be retrieved. It has to be constructed from the knowledge available. This creates an important distinction. Retrieval gathers relevant knowledge. Reasoning determines what that knowledge means in the context of the question. This distinction is important when thinking about how AI systems interact with architectural knowledge. Retrieval-Augmented Generation, or RAG, has become a common architectural pattern for giving language models access to information beyond their training data. A typical implementation takes documents, divides them into chunks, creates vector embeddings, and retrieves chunks that are semantically similar to the user's question. This is useful. Articulate may use semantic search for exactly this reason. But architectural knowledge is not simply a collection of text fragments. Consider the following question. Which business capabilities would be affected if this infrastructure component failed? The answer is not necessarily contained within a semantically similar paragraph. The system may need to follow relationships. An infrastructure component hosts an application component. That application component supports a business capability. The relationship between those concepts itself is part of the knowledge. Semantic similarity can help us find relevant information, but it cannot be the only way we navigate architectural knowledge. This is one of the reasons such as approaches like RAG, graph RAG are interesting. Rather than treating information only as isolated chunks of text, a graph allows relationships between information to become part of the retrieval process. This aligns naturally with the knowledge model introduced in the previous episode. If Articulate knows that a business capability is supported by an application component depends on an integration. That integration uses a messaging platform. The messaging platform is hosted on particular infrastructure. Then a question about infrastructure can be explored through those relationships. The important shift is that retrieval is no longer only about finding information that looks similar to the question. It can also be about navigating the structure of what is known. However, graph traversal is not the answer to every question either. Some questions are semantic, some are relational, some are structured. Others may require several of these approaches together. The important architectural principle, therefore, is not that Articulate should use vector search, a knowledge graph, or structured queries. It is that different questions require different ways of retrieving knowledge. This leads to a broader question. Before Articulate can decide how to retrieve information, it needs to understand what kind of question it's trying to answer. Consider these questions. What depends on this component? Why did we choose this technology? Does this proposal conflict with an architectural principle? What changed between these two architectural states? What evidence supports this claim? Each question requires something different from the system. The first requires understanding relationships and dependencies. The second requires reconstructing the context around a decision. The third requires evaluating a proposal against existing constraints. The fourth requires reasoning across time. And the fifth requires tracing knowledge back to supporting evidence. Calling all of this simply agent reasoning hides an important part of the architecture. The system needs different reasoning capabilities. The first is relational reasoning and explores how architectural concepts are connected. It allows questions such as, what depends on this? What does this support? Which parts of the architecture are connected to this decision? This form of reasoning naturally relies heavily on the relationships captured within the knowledge model. Architecture contains constraints, principles, system characteristics, policies, and previous decisions all influence what constitutes as an appropriate design. Constraint reasoning asks questions such as, does this proposal violate an existing architectural principle? Does this design satisfy the required available characteristic? The system is not simply looking for relevant information, it's evaluating one piece of knowledge in the context of another. Architectural decisions frequently involve alternatives. Comparative reasoning examines options in the context of the problem being solved. The important comparison is rarely a generic list of advantages and disadvantages. An option may be appropriate in one architectural context and unsuitable in another. The reasoning, therefore, needs to consider the requirements, characteristics, principles, and the existing architecture surrounding that decision. Architecture evolves. A decision that is correct today may replace an earlier decision that was equally correct when it was made. Temporal reasoning allows Articulate to understand that architectural knowledge exists within time. It can help us answer questions such as, what did this decision replace? Why did the architecture change? Which assumptions were true when this decision was made? This becomes increasingly important as the knowledge model evolves. Architectural knowledge should not exist without context. Claims may be supported by conversations, documents, observations, and other evidence. Evidential reasoning allows the system to ask, which supports this conclusion? Where did this information come from? And how confident should we be in it? This is particularly important for an AI-native architecture system because not everything discovered or inferred by AI should automatically become accepted architectural truth. These are not necessarily 5 agents. That distinction matters. These are reasoning capabilities. How these capabilities are eventually implemented is a separate architectural decision. This is where the idea of agentic RAG becomes useful. Instead of following a fixed retrieval pipeline, an agent can decide how knowledge should be gathered based on the question it's trying to answer. A reasoning process might begin with semantic search to identify relevant concepts. It might then traverse relationships within the knowledge model. It could then use structured queries to retrieve specific architectural information. The results may reveal that additional knowledge is required, causing the reasoning process to perform further retrieval. The important difference here is that retrieval is no longer a single step before generation. Retrieval becomes part of the reasoning process. The system can decide what information it needs, retrieve it, examine what it has discovered, and determine whether further knowledge is required. But I think even the term agentic RAG risks making retrieval the centre of the architecture. For Articulate, the more useful concept is a knowledge reasoning layer. The knowledge model is responsible for representing what Articulate knows about the architecture. The knowledge reasoning layer is responsible for helping Articulate reason with that knowledge. Conceptually, it sits between reasoning capabilities and the underlying ways in which knowledge can be accessed. This is a conceptual boundary rather than an implementation design. The purpose is to separate two concerns. The knowledge model represents architectural knowledge. The reasoning layer determines how that knowledge should be explored and interpreted for a particular problem. This means an agent should not necessarily need to understand how every piece of knowledge is stored. Instead, it needs capabilities that allow it to ask meaningful questions of the knowledge model. The details of whether those questions require semantic retrieval, graph traversal, structured queries, or a combination of approaches belong within the knowledge reasoning layer. One of the lessons I'm beginning to take from designing Articulate is that starting with agents may be the wrong level of abstraction. It's easy to identify a problem and then immediately create an agent for it. A research agent, a decision agent, an impact analysis agent, and a principal agent. But the existence of an agent tells us very little about the reasoning it actually needs to perform. Before designing an agent, I think the more useful questions are the old age, what problem is it trying to solve? What kind of reasoning does that problem require? What knowledge does that reasoning depend upon? How should that knowledge be retrieved? And what evidence should support the result? Only then does it make sense to ask how the capability should be implemented and whether an agent is the appropriate runtime abstraction. This follows a wider architectural approach I'm trying to take throughout this project. The architecture should emerge from the problem and the capabilities required to solve it. The agents can come later. There is another idea that becomes possible once knowledge and reasoning are treated separately. The knowledge model can tell Articulate what it knows, but it does not necessarily explain how a particular conclusion was reached. A reasoning process may traverse these relationships and conclude that changing the messaging platform could affect a specific business capability. The relationship exists in the knowledge model, but the path taken through those relationships is part of the reasoning process. This suggests a distinction between a knowledge graph and a reasoning map. The knowledge graph represents the connected architectural knowledge available to the system. A reasoning graph represents the path taken through the knowledge while answering a particular question. The reasoning map is not necessarily part of the permanent architectural knowledge. It is an artifact of reasoning, but it may become valuable. It provides a way to inspect how a conclusion was reached. It can show which knowledge was used, and it can expose assumptions. It may allow an architect to challenge a reasoning path rather than simply accepting or rejecting the final answer. This becomes particularly important when AI is participating in architectural decisions. A useful answer is important. Understanding how the system reached that answer may be just as important. The knowledge model establishes the foundation for representing architecture as connected knowledge. Knowledge reasoning adds the next layer. Articulate needs to do more than retrieve information that appears relevant to a question. It needs to understand relationships. It needs to evaluate constraints. It needs to compare alternatives within the architectural context. It needs to reason across time, and it needs to understand the evidence behind what it knows. And it needs to explain how it reached its conclusions. Semantic search, graph traversal, and structured queries remain useful. Agentic RAG provides a useful model for allowing agents to choose between those retrieval strategies dynamically, but none of them individually are architectural intelligence. Architectural intelligence emerges from combining structured knowledge with explicit reasoning capabilities. If Articulate is going to contain agents that perform these reasoning capabilities, how should their intended behaviour be described? This is where DCL enters the architecture, a topic for the next episode. If you're interested in AI native architecture, architectural knowledge, or building systems that reason rather than simply retrieve, I hope you join me for the next episode.